Hey, hello everyone. Let's get started with our warm-up for today. Just FYI, there is a graphic organizer that accompanies today's lesson. So I'm linking it right now in the chat. There is also, if you want a link to the slides themselves, here is a link to the slides. But it's also, everything should be posted on Canvas if you want to follow there. Okay, so here is the warm-up question for today. That's not the warm-up. This is the warm-up. Okay, here's the warm-up question for today. A Toyota Prius, by the way, Priuses are great cars, by the way. A Toyota Prius can go from 0 to 60 miles per hour, which is 26 meters per second, in 10.6 seconds. This is a real life data, A Tesla Model S can go from 0 to 60 miles per hour in 2 seconds. So which car has a faster acceleration? A, is it the Toyota Prius? B, is it the Tesla Model S? C, they have the same acceleration because they are speeding up to the same speed. Or D, neither of them are accelerating. So which of these has the faster acceleration? Let's take a few minutes. We are currently at 11 out of 16 responses. That's pretty solid. Let's shoot for that 100% participation as usual. We need about 5 more people currently. For those of you just joining us, what we have is we have a warm-up question for today. There are slides. There is a graphic organizer that accompanies today's lesson, and there are slides as well. Please fill out the graphic organizer as we are going through today's lesson. And if you want, and you will probably want to open up the slides as well, because there will be a lot of graphs on there. And so when you go into your groups, someone will probably want to have access to the graphs at least. So yes, do that. We are currently at 14 out of 18 responses, 15 out of 18. Let's shoot for 3 more people to hit 4 more people, 15 out of 19. Let's shoot for 4 more people to hit that 100% participation, 15 out of 20. For those of you just joining us, we have a warm-up question for today. A Toyota Prius can go 0 to 60 in 10.6 seconds. A Tesla Model S can go 0 to 60 in 2 seconds. Which car has a faster acceleration? The Prius, the Model S, they have the same acceleration because they're speeding up to the same speed, or neither of them are accelerating. There is a graphic organizer that accompanies today's lesson that is on Canvas. I would highly advise you open it. I actually don't have you need to open it because there will be a lot of graphs on there that we will be trying to figure out today. So if you don't open it, you won't be able to see the graphs. So let's take 1 more minute to get these last. We are currently at 17 out of 20 people. Let's get that last 3 responses in. We are at 18 out of 20. Can we get that last 2 people? We are at 19 out of 20. We just need 1 more person. We have, let's take 15 more seconds. Can we get the last person in? 8, 7, 6, 5, 4, 3, 2, 1. All right. So we are only at 95%, which is okay, but we do want to get everyone to participate. So which car has a faster acceleration? The correct answer is B, the Tesla Model S. So when you go looking for cars, a lot of the times they will try to post their acceleration times. They'll be like, this car can accelerate very quickly. Priuses are not known for their acceleration. Model S's are known for their acceleration. What I want you to do now is I want you to work within your group, I'm going to put you in your breakout groups. I want you to try to create an explanation for why the Model S has a faster acceleration than the Prius. Try to include the two words velocity and acceleration. So even if you are unsure of why the Model S has a faster acceleration, I still want you to try to create an explanation for this. So within your groups, try to create an explanation for why the Model S has a faster acceleration than Prius. When we come back, I expect every person to share what their group says. So be prepared to share. You will type out your answers. You won't say it, but I do expect you to have some sort of explanation written out and ready to go. So I'm going to put you in breakout rooms to try to create, and within your groups, try to create an explanation for why the Model S has a faster acceleration than the Prius. Okay, so thank you all for sharing. What we are going to do now is we are going to type in our responses in the chat, but I don't want you to hit enter yet. So I want every person to type in their or their group's explanation for why the Prius has a slower acceleration than the Model S, why the Model S accelerates faster than the Prius. So I want everyone to type in their chat in the chat, but don't hit enter yet. So we're gonna give everyone, let's say about a minute, maybe a minute and a half to type in your answers. And then when I say go, everyone's going to hit enter. And then we're gonna see what everyone wrote down. So don't hit enter yet. Type in your responses. We'll take until maybe a 10:24. 10:24. So a minute and a half. Type in your responses for why the Model S has a faster acceleration than the Prius. And then in a minute or so, I'm gonna say go. And then I want to see a lot of responses in the chat. We don't want to see a bunch of blank, quiet Zoom chats. We're looking to get this place popping. Get some emojis in here. Get some crying face emojis. So yeah, we've got 50 seconds left. Type in your responses. Get ready to enter. Don't hit enter yet. If you hit enter too early, you lose 1,000 points in this class. Don't jump the gun. We got 35 seconds left. Get your answers ready. Keep typing those out. Doesn't need to be too crazy. A sentence or two is good enough. Just have something ready to go. We are ready to go in. We have a lift off in 20 seconds. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Go. Hit enter. Hit enter. Hit enter. And oh my God, we have so many responses here. All right, keep hitting enter. Keep hitting enter. We have a few of them, but I know we can get a little bit more. Let's get a few more. All right, so I'm gonna start reading them out. If you haven't typed it in yet, please do so. It's faster because it uses electric entirely and doesn't have a combustion engine, based off of a 2016 Insider article. Interesting. Yes, it does use electric entirely, and I'm like how you cite an article. That's good scientific evidence. The Tesla has a faster acceleration than the Prius because it is able to get up to 60 miles an hour in less time than the Prius. Tesla's velocity is able to increase faster than the Prius. Very good explanation. Model S has been designed to go at a higher speed, making it have a high velocity and consistent acceleration. That is an important part of the design. Thank you for sharing. That is excellent as well. The Model S has a faster acceleration than the Prius. It also has a higher velocity because of torque. Torque is actually torque is actually a physics term. And I like how you brought it up. Unfortunately, we won't really talk about torque in this class, but torque is huge in explaining why the Model S has a faster acceleration than the Prius. So good work there. The Model S has a faster acceleration than the Prius because the Model S has a much higher velocity and a lot more horsepower than the Prius. Horsepower refers to the power that an engine of power car produces. A Model S can have 670 to 1,020 horsepower, while a Prius has about 120. The Model S has a much stronger and faster car than the Prius, which gives it a much higher velocity and higher acceleration. Okay, so right there, we have a lot of great usage of vocabulary. We got a usage talking about power, talking about velocity, talking about acceleration. So that is a really good response as well. It's very comprehensive. So thank you for sharing that as well. That is really good. And it does have a much higher maximum velocity and a lot more horsepower than the Prius. So thank you for sharing that as well. The Model S has a faster acceleration because it starts at 0 and it goes to 60 in 2 seconds, giving a velocity of 30 meters per second compared to the Prius, which has a velocity of 5. That is mathing it out, which is excellent. It has a higher velocity. It does. The Tesla's velocity is faster, which makes it have less time than the Prius. Excellent. Acceleration can be defined as and calculated by the change in velocity over the time. When we compare the two cars, we see that both the cars have the same change in velocity, but the Tesla can complete this change in a short amount of time. Thus, the Tesla can accelerate quicker. Excellent, excellent, excellent. The Model S has a faster acceleration than the Prius because it goes from 0 to 60 in 2 seconds. Therefore, it has a faster acceleration. Those are some really good responses. Actually, that shows a lot of good thinking. I'm really liking how you use a lot of good vocabulary in there as well. So thank you all for those who are sharing. So appreciate that. Next time, let's see if we can get some even more responses because I know everyone else has some really good ideas as well. So what we're going to do is we're going to continue our analysis of acceleration today. We are going to be we are going to look at it graphically. We're going to be looking at it mathematically. And we're going to actually try to get a better understanding of what that means to have a better acceleration. So the first thing we're going to do is we're going to look at a graph. So what I have here is I have the Model S. I have the Model S's velocity graphed with respect to its time. So on the y-axis here, I have the Model S's velocity plotted. On the x-axis here, I have the time plotted. And so what we're looking at is we're looking at the Model S's velocity as a function of its time. So what I want you to do is I want you to answer these 5 questions within your group. Remember, you have graphic organizers, by the way, that you have these questions and these graphs as well. I'll link the graphic organizer again. So on the graphic organizer, I want you to answer these 5 questions. I first want you to answer, what is the Model S's velocity at 0 seconds? I then want you to answer, what is the velocity at 2 seconds? I want you to answer, what is happening to the velocity over time? What is the car doing over time? What is happening to the velocity? What's the car doing over time? I want you to answer, how much does the Model S's velocity change every second? And then I want you to predict what the Model S's velocity would be at 3 seconds. So what I'm going to do is I'm going to send you into breakout rooms, and then I want you to answer these questions within your group, put it on your graphic organizers, and then when we come back, we'll take a look at what these answers might be. So go, 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 go within your groups, try to answer these questions. So
Off.
stop. I
Yeah.
don't want to talk to Mr. Who. That's too bad. Okay, so hold on. Okay, so let's go over those questions as a class here. I think we got these I think we nailed these pretty quickly. I think we did pretty well on these. Okay, so first off, what is the model S's velocity at 0 seconds? This is a big fat 0. How do we know that it's 0? Well, we got to look at the velocity y-axis. The velocity is plotted on the y-axis. And so we got to look at what is the y value when our x value, our time is 0. So we're looking at this point right here, 0, 0. So that's how we know our velocity is 0 at 0 seconds. What is our velocity at 2 seconds? Well, we got to do the same thing here, right? We're looking at where is the 2 seconds on the x-axis. It's right here. So we're looking at what the y value is at this point, and the y value here is 2,26. So the velocity is 26 meters per second. Great work, all of y'all. What is happening to the velocity over time? Well, the velocity, as you can tell, it starts at 0, it goes to 13, it goes to 26. So the velocity is increasing over time. So what is the car doing if the velocity is increasing over time? The car is getting faster. It's getting faster, it's accelerating, it's speeding up. How much is the Model S's velocity changing by every second? Well, initially it was 0. After 1 second, it goes to 13. After 2 seconds, it goes to 26. So every second, it's changing by 13 meters per second. Okay. So last but not least, what do we think the Model S's velocity would be at 3 seconds? Well, if it starts at 0, in one second, it goes by 13. So it's 13. And another second, it goes by another 13. So 26. And another second, we add another 13. So it goes up to 39. Not bad, not bad, not bad. I think we killed this pretty well. So what we are going to do now is we're going to go to the next slide here, and we're going to look at another graph. What? Another graph? No way, Mr. Who. Yeah, way. We got plenty of graphs today we're going to look at because we are all visual learners. Okay, so that first graph was not that bad. This graph here is, I think, a teensy-weensy little bit harder. But it's the same idea, right? What I want you to do is I want you to answer these questions. I want you to figure out what is the Model S's velocity at 0 seconds. I want you to figure out what is the velocity at 4 seconds. This third question I want here is going to be kind of hard. What is the Model S doing in the first 4 seconds? And I want you to try to explain this in terms of what is the car physically doing? If you are sitting in the car, what is the car doing? Right. So I want you to think about that. What is the Model S's velocity? 8 seconds. Then I want you to think about what is the Model S's doing in the last 4 seconds. I think this is one of the hardest questions in this particular graph here. So I want you to think about if you are in the car, what are you physically doing in the last 4 seconds? And then I want you to figure out how much is the velocity changing every second. And then I also want you to predict what would the velocity be at 20 seconds. So I'm once again going to send you off into your groups, and then I want you to quickly go through these questions and figure out as many of these as you can. All righty, let's go.
Oh shoot.
Oh no, we're back in the main group. Okay, so let's talk about this question real quick. So first off, what is the Model S's velocity at 0 seconds? Well, the Model S's velocity at 0 seconds is indeed 0. Not, oh my God, I butchered. No, it's 2. So we got to look at the x-axis. When we're looking at our x value of 0, right, we know that the initial, the starting point is actually 0, 2. The initial velocity is actually 2 meters per second. Now, what is the velocity at 4 seconds? We're going to do something similar. We're going to look at where is 4 on the x-axis? It's right here. What is the y value here? The y value here is 0. So we know that the velocity at 4 seconds is 0. So which means that the car is going to be stopped at this point. So if your car is initially moving at 0 at 2 meters per second, and then it goes down to 0, what is the Model S doing the first 4 seconds? Well, it's initially moving in the positive direction because the velocity is positive, but we end up with a 0 velocity. We end up being stopped. So the only way we can go from a positive velocity to a stopped velocity, yes, I did forget the meters per second. Thank you for letting me know. So the only way to go from a positive 2 meters per second to a 0 meters per second is that we have to essentially be braking, right? We essentially have to be slowing down. So we initially are going in the positive direction, and then we are slowing down, so our velocity is 0. Okay. So what is our velocity at 8 seconds? Well, our velocity at 8 seconds here is -2. We're looking at the graph here. Our velocity in 8 seconds is -2 meters per second. So what is the Model S doing in the last 4 seconds? So let's look at this. Let's first identify what it means to have a negative velocity. So a negative velocity just means that we are moving in the negative direction. So when we are moving at -2 meters per second, what's really happening is that we are moving 2 meters per second backwards. So initially we were moving 2 meters per second forwards. When our velocity is negative, we are actually moving 2 meters per second backwards. So essentially what's happening is we are stopped, and then we end up at 2 meters per second backwards. So what happens is we stopped, we switched our car from drive to reverse, and then we hit the gas pedal. So after 8 seconds, our velocity is now at -2 meters per second. So what ends up happening is we are actually speeding up in the last 4 seconds, which makes no sense, right? If our velocity is decreasing, how can we be speeding up? Well, that's because, right, at that point we have switched our direction, and so we were actually doing was we were going faster, but we were just going in the opposite direction. So this is where you got to think about, right? How fast am I going? How fast is my speed changing? And we got to realize that we're switching directions here, so we are actually speeding up. So how much is the velocity changing every second? Well, in 4 seconds, it changed by -2, which means that every second it should change by -1/2. We can also do this by looking at the slope. So the slope is rise over run. So in 4 seconds, our rise should be -2, right? So we're going from 2 to 0. So our rise is actually -2. It's very easy to look at this and be like, our rise is +2. But right, if our rise was +2, this would imply that we were actually going up. But our rise in 4 seconds is actually -2 because our y value is decreasing by 2. And then our run is just 4. So our rise over run should be -1/2. So every second, our velocity decreases by 1/2 meter per second. Not bad, not bad, not bad, not bad. What about the last question? What would the velocity be at 20 seconds? So this is kind of the hardest one. So every second, 1 second, our velocity changes by -1/2. So that means in 20 seconds, our velocity should change by -10, right? So 20 times -1/2 is -10. So after 20 seconds, our velocity should change by -10. So if we started off at +2 and we change by -10, so we subtract 10, our final velocity should be -8 meters per second. Now, this requires a little bit of thinking here. We got to realize that if our velocity is changing by -1/2 every second, if we just multiply that by the number of seconds, right, we can then figure out what our velocity is at 20 seconds, which is just -8 meters per second. Not bad, not bad, not bad, not bad. So what we're going to do now is we're going to move on to the next slide. Oh, by the way, does anyone have any questions on this? Anything you want me to answer? Anything I felt like I went too fast on? All right, all right, all right, all right. So, okay. Okay, so here is what I want you to do is I want you to do is I want you to go, are you supposed to answer the what's going on here question? Um, you mean for the last one? So for the last one, you should answer the what's going on, but for this one, you don't. For this one, oh, for E. Yes, yes, yes. Well, except by what's going on, I mean you're supposed to. So what you're gonna do is you're gonna try to write a story. So by what's going on, I mean you're gonna try to write a story for this graph. So this graph here, you have a initial. So for this graph here, we have a little. For this graph, we have a velocity and a time graph. And what I want you to do is I want you to write a very short story, like one sentence or so, that explains what's going on. So I want you to write a little story that this graph narrates essentially. So what's going on here? We're not going to share it in class because I realize that we can be a little self-conscious about our stories, so that's okay. But what I want to know is I want you to think about what is happening to the velocity in the first second, what is happening to the velocity in the second second, and then I want you to think about how much is the velocity changing every second. So these are some questions that you might want to think about when you are writing a story. So what I want you to do is I want you to tell me what's going on in the graph here in the form of a short story. So what I'm gonna do is I'm gonna put you in your groups again, and then we're gonna give you some time to try to come up with a story that explains what's going on in this graph. So go, 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 go. So let's talk about a story for this. Um, I I heard some really good stories from fifth period. If anyone has any good stories that they want to share in fourth in our period, you can feel free to message me. I'm not asking you guys to, so you guys don't have to. I'm gonna share some of the stories I've read in fourth period that I really liked. One of the best ones I've heard was this was the one that I would have came up with, and I think it was a really good one. So I want you to imagine that you are driving in a car. So basically, for the first second, I want you to imagine you're in a car, you're in a supermarket with your parents. Either you're driving or your parents are driving or your friend is driving. So you're in a car with your parents. And then you are backing up initially, right? You're backing up in your parking lot and out of a parking spot, which is why you're going backwards, which is why your velocity is negative. So you're backing out of a parking spot. And as you're backing up, right, you're initially moving, and then you're slowing down because you're slowing down because you're almost out of the spot. So you're backing up, your car's in reverse, you're slowing down, and at 1 second, your car is stopped, right? You backed out all you needed, and you stopped because you don't want to go out any further. Then what you do is you switch your car from reverse to drive, and then you hit the gas pedal, and now your car is speeding up again, and now your velocity is going to be positive because you're moving forward. You're backing up initially, but you're braking, and then you come to a stop. You switch your car from reverse to drive, and then you go forwards. So that's a good way of thinking about what's going on here, and it helps sort of explain what it means when your velocity is sort of changing. So hopefully that was helpful. What we are going to do now is we are going to do probably one of the first math problems that apply for velocity. So here, oh, something just happened. Okay, so what I want you to do now is I want you to solve this problem. If an object is moving at a velocity of 12 meters per second and it decelerates at a rate of 4 meters per second every second, what would its velocity be at 10 seconds? So once again, if an object is moving at a velocity of 12 meters per second and it decelerates at a rate of 4 meters per second every second, what would its velocity be at 10 seconds? So what I'm going to do is I'm going to put you in your breakout rooms, and I'll give you maybe 5 minutes to figure this out, 4 or 5 minutes to figure it out, and then we'll come back and review this. So go, 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 go. Okay. We got 1 minute left, so I'm gonna do this as quickly as I can. Okay, so what's happening here is that we initially started off with a velocity of 12 meters per second. So if it's decelerating at a rate of 4 meters per second every second, it means that every 1 second, it goes slower by -4 meters per second. It gets slower by 4 meters per second. So after 1 second, our velocity should now be 8 meters per second. After 2 seconds, it should be 4 meters per second. So every second is decreasing by 4 meters per second. So if we want to figure out what the velocity be at 10 seconds, what we need to do is we need to figure out how much does the velocity dechange by in 10 seconds. So what we did is what we want to do is we want to take the amount of time we take multiplied by our deceleration rate, which is -4 meters per second. And we get that our deceleration, the amount of we decelerate in total is -40 meters per second. So we take our initial velocity and we subtract this 40 meters per second. What we get is that our final velocity should be -28 meters per second. All right, so that sums up about what we did today. We got through maybe half of the graphic organizer, so we will continue the rest of this on Friday. So you don't have any other homework, and that is it. I will see you all on Friday. Yeah.
Thank you.
Thank you.
Thank you.
Bye.
Sorry, my uncle's home. That's -28, right?
Yes. See.
Okay.
Bueno.
Double checking. Okay. Bye.
Bye.